Alright, welcome to video 4 of section 9-2. Let's go back and look at our objectives. Identify 3 pathways the body uses to release energy during exercise. Okay, we'll talk about that in just a minute. Explain how high energy electrons are used by the electron transport chain. I want you to know the ATP totals. A great quiz question, by the way, is how much ATP is produced in cellular respiration, with and without oxygen. Remember, with oxygen, it's about 36, and without, it's about 2. So, obviously, oxygen is the right way to go. If you hold your breath for a minute and your body starts to panic, that's what's happening. You're running out of oxygen, which means you're starting to use lactic acid fermentation more. Alright, moving right along. Energy and exercise. Bang! The starter pistols goes off, and the runners push their starting blocks and sprint down the tracks. The initial burst of energy soon fades, and the runners settle down to a steady pace. After the runners hit the finish line, they walk around slowly and breathe deeply to catch their breath. Let's look at what happens at each stage of the race in terms of the pathways the body uses to release energy. To obtain energy, the body uses ATP already in muscles and new ATP made by lactic acid fermentation and cellular respiration. At the beginning of the race, the body uses all 3 ATP sources, but stored ATP and lactic acid fermentation can only supply energy for a limited time. Alright, so we're going to learn about three energy sources the body has. First, quick energy. What happens when your body needs lots of energy in a hurry? It responds to a sudden danger. Quick actions might make the difference between life and death. To an athlete, a sudden burst of speed might win the race. Cells normally contain small amounts of ATP produced during glycolysis and cellular respiration. When the starting gun goes off in a foot race, the muscles of the runners contain only enough ATP for a few seconds of intense activity. Before most of the runners have passed the 50-meter mark, that store of ATP is nearly gone. At this point, their muscle cells are producing most of their ATP by lactic acid fermentation. These sources can usually supply enough ATP to last about 90 seconds. In a 200 or 300 meter sprint, such as figure 9.9, this may just be enough to reach the finish line. Okay? Alright, so what does that mean? That means if there are 3 sources, and remember, that's one of our objectives. Identify 3 pathways the body uses to release energy. Well, the first one is stored ATP. That's what we've already got in our muscle cells ready to go. The second one is ATP from lactic acid fermentation. And this will last you about 3 seconds. This will last you about 90 seconds. And then you got to switch to something else. What's that something else? Let's continue on to page 231. Fermentation produces lactic acid as a byproduct. When the race is over, the only way to get rid of lactic acid is in a chemical pathway that requires extra oxygen. Did you catch that? You have to use even more oxygen to get rid of lactic acid. For that reason, you can think of a quick sprint building up an oxygen debt that a runner has to repay after the race with plenty of heavy breathing. Long-term energy. What happens if the race is longer? How does your body generate the ATP it needs to run a 2-kilometer or more race, or to play in a soccer game that lasts more than an hour? For exercise longer than 90 seconds, cellular respiration is the only way to generate a continuing supply of ATP. Cellular respiration releases energy more slowly than fermentation, which is why even well-conditioned athletes have to pace themselves during a long race over the course of a game. Your body stores energy in muscles and other tissues in the form of the carbohydrate glycogen. These stores of glycogen are usually enough to last for 15 or 20 minutes of activity. After that, the body begins to break down other stored molecules, including fats, for energy. This is one reason why aerobic forms of exercise such as running, dancing, and swimming are so beneficial for weight control. Okay, so the third one, class, you got it, is cellular respiration. What did we learn? We learned that cellular respiration breaks down something called glycogen to fuel the electron transport chain. And glycogen is a carbohydrate. Do you remember what a carbohydrate is? That's just a long chain of sugars put together. Okay, so remember, glucose is basically just a carbon in a ring, and if you hook it together in a special way, you're going to get glycogen. And your body stores glycogen in the muscles so that it can use it quickly. And after 20 minutes, says the text, you run out of glycogen and you start using fat and other sources of energy. That's why they say you should exercise for at least 30 minutes in cardio workout so that you can start burning fat. All right. Why do runners breathe heavily after a race? It's because they're paying back the oxygen debt that they've accumulated with lactic acid fermentation. All right. Let's move on to page 232. And please go to the next video. Page 232, next video.